hi, I'm Mike. I'm a software developer at a company called Consensus. We're headquartered in Brooklyn. We work on Ethereum stuff. Okay, so I was going to say like who's actually written a smart contract, but okay, I guess who's like written a smart contract before? Okay, cool. I'm not like really going to change any of my presentation on the basis of that. Okay, so writing smart contracts is fine. It's not like super hard. But then like managing smart contracts, like managing them over the course of their life cycle can actually be like really difficult. Especially just because, 2 years in, the tooling around the Ethereum ecosystem, if you don't know where to look, you might find that it's a little wanting in some areas. So what is like the life cycle of a smart contract? So there's like developing it, there's testing it, and then there's deploying it, and then there's like living with it. And they never really die because like the blockchain is a server that never reboots. So it is not a life cycle, it's like just a birth. Okay, so I'm going to talk to you about a tool called Truffle, which is developed by a guy named Tim Coulter. He lives up in Yakima, Washington. He developed Truffle initially way back in the early days of Ethereum, like in early 2015. Before the network even launched, he was like writing dApps. There was zero tooling, and he just like wrote this thing to help himself. Early criticisms of Truffle is that it was like this really monolithic framework, and I like shared those criticisms. It was just like a reflection of Tim's brain because it was this tool that he had built for himself. But over time, Truffle has actually become a really nice, pretty modular, extensible tool. Like it still has opinions in it, but I'm going to show you today like how you can kind of extend Truffle in ways that are useful to your own brain. You can kind of get around Tim's brain. So first, we're going to look at some code that does not use Truffle, and we're just going to look at like how painful it is to try to do smart contract development without a framework. So this is a tool that Miguel and Edwin will recognize. This is called Deploy Monster. So this is a tool just for like deploying Ethereum smart contracts. So we have this problem where I wanted to be able, Web3 has like a deployer method, but I wanted to be able to sign raw transactions with any like arbitrary private key and send them to the network. And I was like, oh, that can't be too hard to write. But this code is not great. Like, don't write your own tools. Just use Truffle. But let's just look at like why this is hard. Why is it hard to do something seemingly simple like deploy a smart contract? So first we have these like on line 10 we have this like sanitized deploy options. So we have this like this is in TypeScript by the way. We have this like deploy options input. Like just a bunch of strings. We have a signing key, which is like a private key that's just going to like hang around in some like JSON file. That's not a best practice. We have these TX params. You have to put a nonce in there. In this application, in Deploy Monster, you have to like get the nonces manually, which is like not something you should have to worry about as a developer. So a lot of pain going on. We're only on line 10. Then here, I have this like utility function where I have to order the deployments on the basis of the nonces, because like if you send like a transaction with nonce 5 before you send one with nonce 4 is never going to get sent. That's like a pain. The compiling is actually pretty simple. This you can do yourself. There's like a utility compiling function. You just get like an array of contracts out of the Solc compiler, and then I put them into this other object. That's not so bad. Okay, here's where it really starts to get heavy. Now, here in line 28, we're going to prepend an OX onto the bytecode output from the compiler, and that like seems innocent. Whatever, we have to prepend an OX. But one like failing of Ethereum is that we never really decided as a community when in hex encoding, so you have to prepend the OX and where you don't. Like it's kind of like a crapshoot, like where you have to actually do that. So there was a lot of bugs in this program. Eventually got resolved by like guessing, is there actually an OX prefix here? So this is kind of a prelude to crappy stuff that we're going to get into. Okay, now here's where the really fun stuff begins in this deploy function. Okay, so here on line 39, we're going to instantiate a contract object using Web3, but like we're not like using the Web3 deploy methods. We're just like instantiating a contract object. We're then creating raw transaction data using this get data method. We have to pass in this like TX params data field. This is like the really hairy stuff. We have to sign it using our signing key. We have to like encode this hex buffer. We call it tx.sign. This is from the Ethereum JS library. This is like pretty low level stuff, not something you should ever have to mess with as a developer. You have to serialize it, and then convert it to a hex string, which like I spent like 2 days figuring out why like my thing wasn't properly serialized. Like, we haven't even deployed the contract yet. Like, we still haven't deployed a contract. So we're not going to go through all of Deploy Monster. We eventually got this to work, and it's a fine. If you have the like particular use case where you need to specify an arbitrary private key that you have to deploy a transaction with, use Deploy Monster. Otherwise, definitely don't. Okay, so there's a lot of sharp edges in smart contract development. We're dealing with like weird encodings of things. So let's do something easier than this. Okay, so first I'm going to show you a very, very simple Truffle repo. This is in a project called I Said This. This is just like a little thing I was working on. So I wanted to put a hash. This is like a proof of existence thing. So I wanted to write a message to somebody, and then I wanted to put a hash of that message on the blockchain, such that in the future, if they didn't take the advice I was giving them, I would be able to prove to anybody, hey, I said this, months ago. There's a hash of it on the blockchain. It's signed with my private key. This person chose not to take my advice. So, yeah, this is just a little app that I was working on, and I wrote it in Truffle. So this is a super, super simple app. I'll just use this to show you how Truffle works. Then we'll get into a little more like advanced Truffle stuff. So, show you our contract first. And contract. Sorry, it's hard to get with only one hand. Okay, so we have a super simple little contract here. So we have two mappings, raw to SHA, and then SHA to block num. So raw would be like some text input, like I love cats. That has a certain, SHA-256 hash. And then we have a mapping of, you take the SHA, and then you can see what block number was the SHA inserted in. So we can add a proof by raw. So we send it some text, or I love cats. We SHA-256 that. We put this into our raw to SHA mapping. And then we just call our add proof by SHA function, which puts it into the SHA to block num mapping. Very simple contract. Like I said, like writing smart contracts, a lot of the time is not the hard part of dealing with smart contracts. Not to say there aren't very complex smart contracts out there, but okay. So we walked through Deploy Monster before, which is like this beast of a program, really, really bad. What's an easier way to do this? So Truffle has this notion of migrations. I think migrations is a bad name for what these are. They should just be called like deployers. Yeah.
I was confused. What is it migrating?
Yeah. So they're deployers. So they're called migrations because Truffle supports this notion of like you might want to upgrade a contract. So you might want to you might have like 4 contracts in like a system of contracts that you built. You want to replace one of them. You don't want to spend the gas to replace all 4. Truffle actually does a really elegant job, like a very elegant job of supporting that. And it just handles it for you automatically. Like if one of your contracts changes, it knows which one it is. It's going to redeploy just that one. And what's interesting is it actually deploys. It has a special migrations contract, which it deploys for you, and it manages the state on the blockchain itself. So it's actually really elegant and cool, but 90% of the time, you're not actually using migrations to run migrations, you're just deploying something. So migrations are not a great name. Okay, so this is really simple. This is what it looks like to deploy a contract using Truffle. And it's actually, it can be even simpler than this. So we import our I said this.sol. Let me get my test RPC running, actually. Oh, it's already running. I'll reboot it just in case. This is like an Ethereum node that just mines transactions instantly. Tim also wrote this. Yeah, so if we're in a Truffle project, we can just do Truffle compile. It's going to find all of our contracts. It's going to compile them. Okay, so now we have this I said this.sol artifact. This lives in a build directory. We call this, we have this deployer thing. Now, I do this deployer.then because, as you'll see in a minute, we can do more complex things with the Truffle deployer. But what's even easier is you can just do deployer.deploy. I said, sorry, it's so hard. Type with one hand. I said this. And now, so I'll run this deployer in just a second, but what's cool about this is, so this is like, these are async functions, right, because these are hitting the network. But what Tim has done for you is if you're just like running a bunch of simple deployments like linearly, you can write them like this. Like if you have another contract, you can just do other contract, deploy that too. And these will just run in order, like you don't have to promisify anything. So if we were to run Truffle migrate on that, it's already compiled, so it's down in my build directory. Yeah, but you never have to touch that. Well, I'll show you later why you might want to touch that. Okay, then last thing Truffle does for you. So before we deployed, we should have tested, but whatever, we're reckless. Okay, let's just look at like what a test might be. There's one test for this contract. So Truffle gives you a really nice test harness. It's based on Mocha. So we have one test. Our test is this should add the phrase "I love cats" to the raw to SHA mapping. So we have this raw phrase "I love cats." We're going to get our deployed artifact. So we have the I said this artifact we call deployed on that. It's going to look at what was the most recent like deployed instance of this. It's going to pull that address out and it's going to instantiate an instance of this contract. So I'm going to set this I said this variable to instance so we can address it by name. Then I'm going to call I said this add proof by raw, which is cats. So I'm just calling a contract method. This looks a lot like Web3, except it's promisified. Web3 doesn't have promises, which kind of stinks. So we add proof by raw, then we verify the raw, and then like this test is so bad, we're just looking like is the block number that it was stored in greater than 0? Like was it stored in some block? We're not even looking if it was stored in the correct block. But that's a test. We can run Truffle test, and our test passes. Thank God. Now let's look at something rather more complex, real quick. All right, let me traverse these directories using one hand. Now we'll go to a directory called, where are we now? Oh no, go to dev, truffle demo. Yay. Okay. All right, so this is some code that we've been working on that I've like scrubbed the names out of, so I won't like reveal any secrets. But what we have is a contract to allocate tokens to people who want to purchase tokens. So we'll look at our contract real quick. We have a contract called sale.sol. Okay, so the kind of main thing here is we have a purchase tokens function. We do some checks. We make sure the message value is greater than 0. We make sure that they're trying to purchase an amount of tokens that is actually available. We make sure that they're sending in the right amount of money. If they pass all those checks, we're going to increment their balance in our purchase records mapping. We're going to decrement the total number of tokens remaining. We're going to send the ether that they gave us to our wallet, and we're going to emit an event called purchased tokens. Okay, now this is a tiny little contract. It's 45 lines. There's 11 lines in the path there, but it's so stressful because like this is money, and like you don't want to lose people's money. So wrote a big old test suite for this little 45 line contract. Yeah, there we go. All right, so we really want to be sure that we're not going to lose anybody's money. So let me show you some of the stuff we're doing with our deployer here. Now we have some kind of edge cases here that Truffle is actually not natively good at handling. So we were talking before about migrations in Truffle and how like if you deploy a contract and then you deploy another version of that contract, Truffle assumes that you just want to like replace your old version. What we have going on here is kind of contrary to Truffle's assumptions. We want to have multiple sale contracts. We want to have like different groups of buyers potentially buying tokens at like different prices. We want all that money to go to like one wallet contract. Was that a question or a cough? Okay, I guess it was a cough. Yeah, so like if you just try to do this in Truffle, it's just going to like keep overwriting all your stuff, and that doesn't work so well. So we have to kind of like work around that a little bit. So what do we do? Okay, we're gonna work around kind of like some of Truffle's native things. So we'll skip down to the sale contract section. Up here, we're like, I have some input files that are just JSON. We're checking like if the seller wants to deploy a multi-sig wallet, we'll deploy that multi-sig wallet. We'll save the address of that wallet, and we'll like resolve that back into the seller object, which will later like persist to disk down here. This is like a little utility to write sellers. This is how we kind of get around some of Truffle's native assumptions. So we have an array of sellers, like different people who are going to be selling this token and all sending their funds to the same wallet. We're going to deploy sales for all of them, so we're just going to like map over this array. We deploy sales. We save now these are all like their own distinct promise chains, because remember like Truffle is completely promisified, so on line 90 here, sale.new, this creates a new promise chain. We capture that, and then at that point, execution in the map goes to like the next item, so like it's happening in parallel, but it has different contexts. We're going to capture the address of the deployed instance here, put that into like the seller object that we passed in, resolve that. Eventually what we get out of this is another array of like our own seller objects. These aren't the Truffle like contract artifacts. These are our own seller objects that have these arrays, or have these addresses rather, saved inside of them. Okay, so that's like doing a little funky stuff with the deploy pipeline. Now, I work with Miguel, and we have like a front end for some of these, sale contracts. Truffle works in the front end, like it's natively designed. Yes, 2 minutes. Okay, great. Truffle like natively works in the front end, so we want to like send the contracts and the addresses to the front end. But we have this thing where we have like artifacts, and then separately we have like our addresses saved. So this is just like a little utility script that I wrote, prod deploy.js. So this is like kind of outside of Truffle, but it's like building tooling around Truffle. So I'm just going to do like exec sync, frankly, for a bunch of like external Truffle processes. I'll kill the build directory, I'll recompile everything. Then I'm going to run this Truffle migration. We're going to raw instance. This is really like prod deploy. So I have a utility function that gets all my sellers. They're separate, again, from the like Truffle contract artifacts. We sent the contract artifacts to S3 up here. So here we have our sale artifact. We upload that to S3. Then separately, we upload the addresses for these things. Then Miguel just like pulls those out of S3 on the front end, and these have like IDs. So we see like, okay, give me the address for this ID that I'm working with. And then you do like the name of the contract with like sale, so you do sale.at with that address, and then you have a fully instantiated version of that contract at that address in the front end. So you can kind of like, you can make Truffle expand to meet your needs, and still like take advantage of all of its like really nice, promisified contract methods and stuff. And then there's just like our big friggin' test suite. So in theory, all the sale contracts we deploy should be identical. In practice, I'm paranoid, so we like run our tests over every single deployment, because like that's safe and I don't want to lose anybody's money. Anyway, that's Truffle. If you have questions about Truffle, I'll be around afterwards. This is probably like too fast and like too much for some people and not enough for others, but yeah, let's talk about it if you have any questions. Thank you.
First question I have is the code that you wrote, can I get it from GitHub, or is it completely
I can, so which code? The deploy monster code? You can have the deploy monster code. Yeah, that's free, man.
I want the code that actually does the sale and
I would love to open source it. In fact, we probably can, because I took out all the identifying information. Yeah, sure.
The reason is just to learn how you're writing, because there's not good documentation. Like, I feel like completely write a test suite myself right now.
Yep.
Just because
I
just read through the Truffle code itself, actually. So
yeah, I would. So I've obfuscated all of the stuff, so I think we can share it.
Yeah.
Let me run it by the suits, and we'll be sure about that, but I'd love to share it.
And the utils?
Yeah, I'd love to share the whole repo.
Yeah.
Yeah, just gotta make sure I took all the secrets out.
Yeah.
Okay, cool. Any other questions? I'll be around afterwards too. Cool, thank you all.
Thanks.